Hello class, today we are looking at segment addition proofs. The essential question is, how do I apply the segment addition postulate? My learning intention: I am learning to apply theorems and postulates to find unknown measures and prove my answer is correct. For the warm-up, you need to write the if-then statement, the converse and the inverse, and the contrapositive. So the statement is, collinear points lie on the same line. Please pause the video and write these statements. I hope you tried. So let's write the if-then statement. If points are collinear, then the points lie on the same line. Okay, so that is your if-then statement. The converse, if you notice, I've given you directions for doing that. The converse says the P switches with the Q. So this is in the form of if P, then Q. So your P is your hypotheses, and your Q is your conclusion. For the converse, all you do is switch the points, switch their positions. So if the points lie on the same line, start with what you ended with. Then they are collinear. Okay, for the inverse, all you're doing is, this means I'm negating. I'm changing it to a not. I'm negating. I'm changing it to a not. And you start with your if-then statements, if the points are not collinear, then they do not lie on the same line. Okay, if the points are not collinear, then the points do not lie on the same line. The contrapositive, you switch them around. So you can look at your inverse, because the contrapositive is to negate your conclusion and then negate your hypotheses. That little thing means not. So for the contrapositive, if the points do not lie on the same line, then they are not collinear. Then the points are not collinear. Are all these statements true? Yeah. Collinear means that they lie on the same point. So if they lie on the same line, they're collinear. If they are not collinear, they are not on the same line. If they are not on the same line, they are not collinear. All of those are true statements. Okay, so that takes us down to our segment addition postulate. The segment addition postulate states, in a line segment, the sum of the lengths of the smaller segments is equal to the length of the original segment. If you will notice, this is a postulate. What does that mean? A postulate we use without ever having to prove. Now, recently we proved the vertical angle theorem. We did a proof to show that vertical angles are always congruent. In this case, you don't prove because you could not take every example in the world and solve it. So a postulate is something we just understand this is going to be true without ever having to prove it. So we're going to find the missing length on the first one. So what do you notice and how do we use it? Well, 13 is the whole length. RT is 13. So if we're looking for ST, we've got to remove that extra piece. So it'll be 13 minus 1, which gives us 12. So 1 plus 12 gives me 13. That's what our postulate states. This plus this will give me the total length. How about the next one? How can we find the length of KL? What do you notice and how do you use it? Well, IL is the whole thing, and IL is 26. So to find KL, I start with the whole thing, and I subtract both of these pieces. Okay, 26 minus 9 will be 17. 17 minus 11 will be 16. No, it won't be 16. It will be 6. 17 minus 11 is 6. So this is 6. The other way you could have looked, if you would have looked up here, gee, 9 and 11 is 20. The whole thing is 26. So 26 minus 20 gives me 6. If you have any questions, back the video up and watch parts of it. Okay, so we always like it to get harder. This time we're going to find IK. Where is IK exactly? So I'm going to find that, but I know the whole thing is 49. How do I use that? Okay, so we're going to actually drop down and look at the bottom. This doesn't give us what we need, does it? But we know that it will give us the length of IJ. Once we find the length of IJ, then we can find the length of IK. So what is the length of IJ? So we know that IL is equal to 49. IJ is equal to 49 minus 31, because from here to here takes JL, and that leaves me with IJ. 49 minus 31 is 18. So I now know that this piece is 18. Now what do I do to find IJ? IJ, you'll add, or IK. IK, you will add them together. Okay, so that is 30. From here to here is 30. What is the length here? 49 minus 30 would give me 19, and I have found all the lengths. The other way we could have found it, 31 minus 12 would also give you 19. Okay, looking at the next one. Pause the video and see if you can think it out. Can you write out the equation we need to find x? Well, we know the whole thing is 33. We know it's three pieces, this plus this plus this. So we'll add them together and they will equal 33. 3x minus 28 plus 3x minus 30 plus x equals 33. About ran out of room. 3x plus 3x is 6x plus 1 more is 7x. Negative 28 plus negative 30 is minus 58 equals 33. Let's solve. I'm going to add 58 to both sides. $7x is equal to 3 plus 8 is 11, carry the 1, 8 plus 1 is 9. 91. What is 91 divided by 7? Okay, 7 goes into 9 one time. Then you'll have 21 left over. So 21 divided by 7 is 3. So we've got 13. This one is 13. If I needed to, could I find those other two lengths? Well, yeah, I would use substitution. Okay, 3x minus 30. 3 times 13 minus 30. That would be 39 minus 30, which would give me 9. For the last one, 3 times 13 minus 28. 39 minus 28. That would be 11. So I have now figured out all those missing lengths. Okay, pause the video again and see if you can figure out how to do this. As you're looking at this, What do you know and how do you use it? Well, we know that the whole thing is 3x minus 1. If I'm looking here, I've got an overlap. How does that affect? I know that overlap is 2. How does that affect? Okay, let's see. If I'm looking at this piece here, it would be 2x minus 3. Or minus 4. Okay, this includes that 2-unit piece. Plus 2x minus 3. That also includes that 2-unit piece. I've added that 2-unit piece twice, so I need to subtract it off once. And this is equal to 3x minus 1. I'm going to move this down so we can have this big long equation and work it out. Okay, so 2x minus 4 takes me to here. Plus 2x minus 3 takes me to the end. But I've added this 2-unit segment twice, so I've got to subtract it. And that is equal to 3x minus 1. Okay, combine your like terms. 2x plus 2x is 4x. Negative 4 plus negative 3 is negative 7, plus negative 2 is negative 9. Any questions? Okay, let's solve for x. Subtract 3x from both sides. X minus 9 is equal to negative 1. Add 9 to both sides. X is equal to 8. Okay, so if I want to find the whole length, I know what x is equal to, and I know what this is equal to. But it's asking me to find DE. This is DE. I know it is this much minus that 2. So I'm going to set it up as an equation. It will be 2x, or 2 times 8. X is 8. Minus 3, and then minus 2 more. 16 minus 3 minus 2. 16 minus 3 is 13. 13 minus 2 is 11. So this piece would be 11. What about this piece here? How can we find BC? Okay, the whole thing is 2x minus 4. So this would be 2 times 8 minus 4. But once again, we've got to remove that 2. 16 minus 4 minus 2. 16 minus 4 is 12. Minus 2 more is 10. So what is 3x minus 1 equal to? (11 plus 2 plus 10). So 3x minus 1 is equal to 23. Once again, you'll end up with x is equal to 8. We could have substituted 8 in for the whole thing also, but that was a different way to look at it. This is the segment addition postulate, and I know I'm successful when I can find missing measures using the segment addition postulate. We are adding segments.